As I mentioned earlier, a preemptible VM is an instance that you can create and run at a much lower cost than normal instances. See whether you can make your application function completely on preemptible VMs, because an 80% discount is a significant investment in your application. Now, just to reiterate, these VMs might be preempted at any time, and there's no charge if that happens within the first minute. Also, preemptible VMs are only going to live for up to 24 hours, and you only get a 30-second notification before the machine is preempted. It's also worth noting that there are no live migrations nor automatic restarts in preemptible VMs. But something that we might want to highlight is that you can actually create monitoring and load balancers that can start up new preemptible VMs in case of a failure. In other words, there are external ways to keep restarting preemptible VMs if you need to. One major use case for preemptible VMs is running batch processing jobs. If some of those instances terminate during processing, the job slows, but it does not completely stop. Therefore, preemptible instances complete your batch processing tasks without placing additional workload on your existing instances and without requiring you to pay full price for additional normal instances. If you have workloads that require physical isolation from other workloads, or virtual machines, in order to meet compliance requirements, you want to consider sole tenant nodes. A sole tenant node is a physical compute engine server that is dedicated to hosting VM instances only for your specific project. Use sole tenant nodes to keep your instances physically separated from instances in other projects, or to group your instances together on the same host hardware. For example, if you have a payment processing workload that needs to be isolated to meet compliance requirements. The diagram on the left shows a normal host with multiple VM instances from multiple customers. A sole tenant node is shown on the right, and it also has multiple VM instances, but they all belong to the same project. As of this recording, the only available node type can accommodate VM instances up to 96 vCPUs and 124 gigabytes of memory. You can also fill the node with multiple smaller VM instances of varying sizes, including custom machine types and instances with extended memory. Also, if you have existing operating system licenses, you can bring them to Compute Engine using sole tenant nodes, while minimizing the physical core usage with the in-place restart feature. To learn how to create nodes and place your instances on those nodes, see the link section of this video. Another compute option is to create a shielded VM. Shielded VMs offer verifiable integrity to your VM instances, so you can be confident that your instances haven't been compromised by boot or kernel level malware or rootkits. Shielded VMs is the first offering in the Shielded Cloud Initiative. The Shielded Cloud Initiative is meant to provide an even more secure foundation for all of Google Cloud by providing verifiable integrity and offering features like VTPM shielding or sealing that help prevent data exfiltration. In order to use these shielded VM features, you need to select a shielded image. We'll learn more about images in the next section. Confidential VMs are breakthrough technology that allows you to encrypt data in use while it's been processed. Google Cloud's approach to encrypt data in use is simple, easy-to-use deployment without making any code changes to their applications or having to compromise performance. You can collaborate with anyone, all while preserving the confidentiality of your data. A confidential virtual machine, or confidential VM, is a type of N2D Compute Engine VM instance, running on hosts based on the second generation of AMD EPYC processors, codenamed Rome. Using AMD Secure Encrypted Virtualization, or SEV, Confidential VM features built-in optimization of both performance and security for enterprise-class high-memory workloads, as well as inline memory encryption that doesn't introduce significant performance penalties on those workloads. The AMD Rome processor family is specifically optimized for compute-heavy workloads, with high memory capacity, high throughput, and support for parallel workloads. In addition, AMD SEV provides for confidential computing support. With the confidential execution environments provided by Confidential VM and AMD SEV, Google Cloud keeps customers' sensitive code and other data encrypted in memory during processing. Google does not have access to the encryption keys. You can select the Confidential VM service when creating a new VM using the Google Cloud Console, the Compute Engine API, or the G Cloud command line tool.